Okay, my calculus friends. Today we're talking about inverse trig functions. Inverse trig functions. Okay, so sometimes we saw that as sine inverse, right? That's notation that you should be familiar with. Or we had the word arc. So arc sine or arc tan, arc cosine, arc secant, arc cosecant, right? All those things are inverse trigs. So today we're going to learn about how to take the derivative of an inverse trig function. Okay, and it's a formula that, I don't know, you should probably memorize one or two of them, like the sine, the cosine, and the tangent, but for the rest of them, maybe not so much. So, hearkening back to our pre-cal days, right, if we talked about the sine function, okay, the sine function starts at 0, has a period of 2 pi where it's 0, and then it's 0 in the middle. Okay, so this was a graph of our sine function. If you remember, even if you don't, that was the graph of our sine function. Okay, now, if we look at the inverse, right, the inverse of the sine function as it is not a function. So sine is not invertible, right? So if it's invertible, that means the inverse of the function is also a function. But if we do that for sine, notice how it fails the horizontal line test, which means its inverse would not be a function. But there's a way that mathematicians have around that, and that's to take out our eraser and erase a lot of this graph until it is invertible, right? So I'm going to erase everything except for this tiny little domain. So if I leave my domain from, this happens to be negative pi over 2, by the way, or negative 90 degrees, to positive pi over 2, which is positive 90 degrees. I get all of the possible y values I'm ever going to get for sine, right? The smallest y value for sine is negative 1, and the largest y value for sine is positive 1. So if I just think about from negative pi over 2 to positive pi over 2, I get 1 of every possible y value for the sine graph. Okay? That's how we get around this business of it not being invertible, is we restrict the domain. And that's what this first part about this worksheet is talking about. Okay? This is for cosine. If I take cosine from 0 to pi, right, the top half of my unit circle, I get all of the possible y values. I get positive y values and I get negative y values, right? I get all of them. They don't repeat. Cosine does not repeat from 0 to pi. So that's the domain for my arc cosine, or my inverse cosine. Same thing with secant and same thing with cotangent. Okay, but notice not pi over 2 for the secant, because that's where secant is undefined. Because cosine is 0 and 1 over 0 is undefined. Okay, so for cosine and secant and cotangent, I take the domain from 0 to pi, and from secant, cosecant, and cotan, a regular tan, I take the domain from negative pi over 2 to pi over 2, and that gives me all of my possible y values. Okay, so what does that look like in practice? Well, arc sine is asking you at what angle does sine have equal negative 1/2, right? That's basically what we're asking. The answer to an inverse sine or an arc sine problem is an angle. So what is the angle on our unit circle where sine equals negative 1/2? Okay, so hopefully you memorize your unit circle, but that happens right here, where the cosine is root 3 over 2 and the sine is negative 1/2. And that happens to happen at negative pi over 6. So the answer to arc sine of negative 1/2 is negative pi over 6. Arc sine is never going to give you an answer greater than 90 degrees, right? Pi over 2. It will give you negative 90 degrees and all the negative degrees between 0 and 90, and it will give you all the positives between 0 and 90, but it will never give you like 100. You can never get the sine angle and the answer be 100. That's just not possible because of the domain. From negative 90 to positive 90 are the only answers you're ever going to get. So those are the only answers we're ever going to give. What about cosine? Right? At what angle, that's what this is saying, at what angle is the cosine equal to negative root 2 over 2? Okay, the cosine. What angle is cosine negative root 2 over 2? So up here, right, we're looking at the second quadrant. This is where cosine is negative, and this would be 135 degrees, or 3 pi over 4 in radians. Okay, so cosine will never give you a negative angle as an inverse answer. It will always give you between 0 and 180. So the answer to this is 3 pi over 4. 3 pi over 4. And then this one says, what's the inverse tan of negative 0.3? And it says to use our calculator. Okay, so we're going to know that it should be coming from down here somewhere, right, where our tangent is going to be negative. Okay, that's really nice. Now let's move down here. More evaluating. The arc cosine is 4/5. Well, to the best of my knowledge, 4/5 is not an angle on the unit circle, is it? No. But what type of things have cosines are right triangles? So I can draw myself a right triangle where the cosine is 4/5. That means the adjacent side is 4 and the hypotenuse is 5. And here is my angle where the arc cosine is 4/5. Okay, so then the question is, what's the sine of that angle? Well, sine is what ratio? Opposite over hypotenuse. So if I have a hypotenuse of 5 and an other side of 4, that means my missing side has to be 3 because that's a Pythagorean triple. So then my trig ratio for sine is going to be opposite over hypotenuse. So the sine value where the cosine is 4/5 is going to be 3/5. So if we're not talking about the unit circle, then we have to make a triangle. Okay, maybe something like that. Right, we have your right triangle. Here's your angle x. The cosine is the adjacent over the hypotenuse or something. Okay, so if we knew what the hypotenuse and the adjacent were, then this would be our ratio, right? Which we don't know, so we're just going to leave it as that nice equation. Okay, the problem is all these things have nice equations, but they're not really nice. Maybe they are. I haven't actually met them. So let's see. It says we can derive them using the inverse trig functions by implicit differentiation. So let's see if we can do that. Okay, so we know that y equals arc sine of x. Okay, what does that help us do? Probably not a whole lot. Since I don't know what the derivative of arc, how do we get rid of arc sine then? If I don't know what the derivative of arc sine is, I need to change that into something that I do know the derivative for. How do I get rid of arc sine? If I take the sine of the arc sine, right? So that's its inverse function, right? If I want to get rid of a function, I multiply it by its inverse, or I take the inverse of it. Okay, so if I want to get rid of sine inverse, then I take the sine of that. Okay, so I'm looking at sine of y equals x. Sine of y equals x. Okay, so now let's take the derivative. Is that clear? That in order to get rid of your inverse, you would take the normal trig of it? Right? Since we don't know what the arc sine derivative is, we have to manipulate it so that we have something we do know what the derivative is of. So now let's take the derivative of this equation with respect to x. Okay, so what is the derivative of sine of y with respect to x? Right, cosine, so the derivative of sine is cosine. So we do this one at a time using the chain rule. And then what's the derivative of y? Right, y prime, or dy dx. And what's the derivative of x? Well, that's just 1. Okay, so if I want to solve this for y prime, what would my next step be? To divide by cosine of y. Right, cosine y. So I have a problem here. Now I have an x to begin with, but now I have a y down here. So there has to be something we can do to replace cosine y with. So let's think about some other relationships between sine and cosine, shall we? Do you know of any relationships between sine and cosine? Right? We know a Pythagorean identity. Hopefully we know a Pythagorean identity that says the cosine squared of some angle, let's just call that angle y, plus the sine squared of that same angle equals 1. Okay, cosine squared plus sine squared equals 1. That's our Pythagorean identity from trigonometry. Okay, and because I have cosine down here, I want to solve this equation for cosine. Okay, so let's do that. We're going to subtract the sine squared to that side. Cosine squared y equals 1 minus sine squared. Okay, that's true. How do we solve a square? Take the square root. So the cosine of y is the square root of 1 minus the sine squared of y. Okay, so that's what we're going to do. We're going to come and we're going to put that down here in our denominator. We have just figured out what our cosine was. But we still have this tricky sine squared of y business. Right, we still have y there. So what else do we know about sine of y? Well, over here in our first part of our problem, we decided that the sine of y equals x. Right? In that very second step, when we took the sine of both sides, we know that x equals the sine of y. So I can replace sine of y with what letter? With x. Okay, I can replace sine y with x, and what is happening to sine of y underneath our radical? It's being squared. So our derivative of arc sine, since y prime was arc sine up there, is 1 over the square root of 1 minus x squared. Okay, so it's a formula that is driven by using the Pythagorean identity for sine and cosine, right? Not something that you might ever have to do in your life. Just memorize the formula. So these are all of your formulas, okay? And they're a pain in the butt to derive. So just, if you need them for something, just ask Google, and it will bring up a worksheet or something that has them all on there, okay? You probably need to learn for AP class, AP calculus, the sine and the cosine, and the tan. Those are the ones that are normal. So let's see if we can use this to find the derivative of arc sine of 2x. Okay, so the formula says, in the numerator goes the derivative of your parentheses. So the derivative of 2x is 2. So we have a 2 in our parentheses. And in the denominator, 1 minus 2x quantity squared, which we know how to do 2x quantity squared. 2x squared is the same as 4x squared. So that is the complete answer. Now, if they wanted to tell you here you had to evaluate it at pi over 3, then you would replace x with pi over 3. Okay? Okay, the next one, arc tan of 3x. So we have the derivative of 3x in your numerator, which is 3. And we have 1 plus 3x quantity squared in the denominator, which we simplify. And that's going to be your final answer. And then they tell you a point, you plug the point in for x. Okay? So arc secant of e to the 2x. Here is an interesting one. The derivative of e to the 2x, right? This is your u. So that's 2e to the 2x, because it's a chain rule. Anytime we take an e derivative, the derivative of e is itself times the derivative of the power over absolute value times the square root of e to the 2x squared minus 1. Okay? So there's a lot of things going on here. 2e to the 2x over e to the 2x, right, is always positive anyway. So he doesn't need absolute value bars around that. Over e to the 4x squared minus 1. Okay, you could probably divide e to the 2x by e to the 2x to simplify down to its final form of e to the 4x squared minus 1. Okay, so anytime we're taking a derivative of a trig, we're going to use the formula and simplify it as much as we possibly can.